All right, hi everyone. Coming to you about Boyle's Law. Um, Boyle's Law is kind of a cool one. Maybe it's one you're not familiar with, but as I increase the pressure, I decrease the volume. Now, if you've ever experienced one of those eyedroppers, plungers, or like one of those baby medicine feeders, even a pipette, one of those things. If you have access to one of those or ever want to play with one of those, you could cover your finger off the top part, kind of where the liquid would come out, and squeeze down and push down on that, making the volume smaller, and then you can feel the increase of the pressure on your finger. That is a real live example of Boyle's Law. But to solve Boyle's Law, the equation is P1 V1 equals P2 V2. And what I would expect you to do and want you to do is list all the variables along the left-hand side. This is part of your points for doing these problems, and you simply plug in numbers. So I have 2 liters of a gas, so that's the first volume listed. So I'm going to write 2.0 liters of a gas at 740 mmHgs. That stands for millimeters of mercury. That would be my next pressure, 740 millimeters of mercury. So that's what your current gas is. And it asks what is its volume. So that's my volume that I'm looking for at standard pressure. Now, remember standard pressure, STP, is any one of these that are listed up here. So any one of these I can use as my standard pressure. Now, I also told you in a previous video that you have to make sure your pressure units match. And since I'm currently using millimeters of mercury right here, I want to make sure I'm using millimeters of mercury. So the one that has millimeters of mercury is right here. That's the one I'm going to want to use. So I just have to remember 760 millimeters of mercury. And that's going to go in as, my my next pressure. So I then have all my variables there, and I'm going to be solving for V2. So it's P1 V1 equals P2 V2. Writing the equation is part of the work, and then plugging everything in. 740.00. Volume is 2.00 liters. My pressure 2, remember, is standard pressure, so that's 760 millimeters of mercury. And I'm solving for V2. So V2. And I would simply take these two things, multiply these two things first, and then I'm going to divide by 760 just to make sure our order of operations comes out. So 740 times 2 divided by 760 is going to give you a volume of 1.947. And so V2 equals 1.947. And you're starting out with basically 3 sig figs from what you're given. So this would round to 1.95, and that would be liters. Hopefully that makes sense. Let's try the next one. Example 2. Again, I expect you and want you to be writing all of your variables along the left-hand side. Pressure 1, volume 1, pressure 2, volume 2, and let's plug this stuff in. So I have this volume. I know it's volume because it's liters, so 5.00 liters of a gas at 1.8 ATM, 1.088 ATM. It asks for what pressure is obtained, so that's my unknown. That's what I'm looking for when the volume is adjusted to 10.0 liters. So write your equation, P1 V1 equals P2 V2. Plug everything in, 1.0 ATM, volume 5.0 liters, pressure is what we're looking for, and then I have 10.0 liters. Multiply and then divide. I'm going to divide this side by 10 liters, divide this side by 10 liters, And my P2 is going to equal 1.08 times 5 divided by 10. And my new pressure is 0.540 because we need 3 sig figs. Since I started in ATM, I'm going to end in ATM.